Hello and welcome to the webinar in 12D's Industry Solutions webinar series.
My name is Lisa Stewart and I'm the Marketing and Communications Coordinator at 12D Solutions. Our Industry Solutions webinars are designed to provide insights into overcoming challenges in an evolving industry in more effective and efficient ways. We'll keep running these webinars regularly and recording them for posting on our YouTube channel with links to our website. Our first 32 webinars from this Industry Solutions series, as well as the 37 webinars from our training series, are available online if you missed those. During this live presentation, you'll be able to type your questions along the way. We'll put some instructions on the screen. We'll answer as many as possible throughout the webinar. At the end, I'll also read out some of your questions to the presenter if there's time. Today's webinar, BIM Workflow, will be presented by Joel Alsop, who has worked in 12D model support and sales for Extra Dimension Solutions, our 12D distributor for New South Wales, ACT and South Australia, for over 4 years. Prior to that, he had 20 years of experience in engineering with a variety of organisations within New South Wales. This webinar will illustrate the use of 12D model with BIM functionality, taking you through the whole workflow from start to finish. Over to you, Joel.
Thank you, Lisa, and welcome everyone to today's webinar. Today we're going to run through briefly what is BIM, coordinating with architectural structural data, importing data, and how civil sort of fits into the BIM world and exporting data back out to sort of architectural and structural packages. So what exactly is BIM? Well, by now most people will have heard the word BIM. A lot of people think it means some things, a lot of people think it means others, and a lot of people just have no idea what's actually going on. So here's a 60-second rundown. So what is BIM? Well, BIM is not an application or software. BIM is not a file format. For some, BIM is a 3D model containing every nut and bolt in a building. For others, BIM is the information about every nut and bolt that is more important than the model itself. And both are kind of correct. So what exactly is BIM? Well, Building Smart quotes an extract from the US National Building Information Model Standard, and Building Smart Australia uses a slightly reworded version. Basically, BIM is about modelling the life cycle of a building. The main thing behind BIM is about recognising the need for vendor-neutral, non-proprietary methods of exchanging information throughout a project. Bit of a mouthful. BIM, in simple terms, refers to sharing and collaboration, exchange of data, open file formats, and is vendor-neutral. Now you know what BIM is. So exchanging data with 12D model. Well, we've got a few options available. We've got IFC files, we've got FBX, we've got OBJ, we have XYZ, we have 12DA. Yes, 12DA is an open format file, and many, many more. Coordinating with architectural data. So how can we get architectural data into 12D model? The most common format now is the IFC file, the Industry Foundation class. It's open format and it's widely accepted. And it looks something like this. But what does the model actually look like? Let's have a quick look at a file. So over here we've got a program called Celebri open, and we can see here's our building. We've got lots of nice frames. We zoom in a little bit. I know it's going to be a little bit slow, but we can see there's furniture inside the building. So this is what they call a BIM model. It's the full 3D model of the building. We can click on things and we can get information. Over the side here, we can see quantities. We can see it's a wall. There's identification. The wall has a name. It's got a type and a layer and things like that. So it's all about the model. It's all about the information. So what can we actually do with all this in 12D? Well, now we can actually read IFC files in, which makes it a lot better. But how can all this help us? Well, let's run through. So what do we get? Well, we get the building, obviously. We get the information that comes with the building, and we get the model, the 3D model itself. Now buildings. Of course, from the architect, the building's going to come in at 0, 0, 0. But that's okay, because we know where the building should be. In 12D model, we can manipulate data. We can translate, we can rotate, we can scale, we can do 2D and 3D helmets. Now, the simplest method of positioning data is, of course, just a simple rotate and a translate, but it's potentially not accurate. We can do a helmet 3D, but we need a few things. We need a control point, which is where the building should be, and we need the observed point, which is where the architect has put it. Information. In an IFC file, they have something called property sets or P sets that come with the IFC file. When that comes into 12D, they're automatically converted to attributes. We've also got something called an IFC properties viewer, and it's the same information, just in a different format. And we'll have a bit of a look at that later. Modeling. So apart from looking very nice and pretty, is the model actually useful? Well, yes. In clash detection now, we can use tri-meshes as part of our clash detection. So we can do things like checking our utility locations against the footings of a building. So let's take a look. Now I've got a few views open here, and I've got two views open. One, you can probably see 4 points on the screen, and over in the other view, we've got 4 points again. In our left-hand view, this is where the architect has put the building. It's down around 0, 0. On the right-hand view is our building pad, and this is where we want the building to actually be. So we'll go ahead and we'll read in our IFC file. Now all our BIM tools are sitting up under the File menu. I've got File down here and BIM. So I'll just pull that menu out. And you can see on our import here, we have the IFC Express Reader. So we can go and grab our IFC file, which is our building. We want to split the data into entity models. So what that's going to do is break it up into things like footings and beams and furniture and windows and doors and everything like that. And we'll prefix it all so it's a bit easier to find. Just read that in. Now if we have a look at our models, we've got this about 20 or so architectural models. So we'll just go and add them to our view. And there's our building, how it looks in 12D. It's a bit messy, but it's all tri-meshes. Now there was some extra information which we brought in which we don't really want. So I've got a little chain which I'm going to run. And it's just going through deleting a couple of models that I know already that we don't need. So I'll just run that. Now to show I'm not cheating, I'm going to add the same models to our other view. So you can see there's nothing there at the moment. Now we're going to helmet this into position. Up under utilities, we've got utilities, H to Z, and 3D helmet. Now any surveyors in the audience will immediately recognize what this is, as they commonly use it because they're the ones dealing with setting out buildings. Essentially all we do is we have control points. We have control points and we have observed points. So a control point is where the building needs to be. So we have point 1 here, we select that, and we select the matching observed point. And you'll see it draws a line. We can keep going, we can select point 2, we can select point 2, and so on. Thankfully, you can actually save all this out. So I'll load in one that I prepared earlier. We'll just read that in, hit the calculate button. Now we just need to select the data we're going to translate. So we'll do a model list. And we'll grab our models from the arc view. Just populate that. Remove the one we don't need. And you can see we've got all our architectural models in here. We're going to replace the existing data. So we'll do the magician trick. We'll throw our cover over the data there and hit helmet. And it magically appears over here. There we go. Simple as that. Building is now in the correct location. If we jump into our 3D view, we can add all those models back in. And there's our building. And as mentioned, we can interrogate this. So we might just take out the windows at the moment so we can see inside. Oops. And we can see our furniture in there. So we come up to our utilities. Oops, sorry, what's that? Strings, properties, attributes. We can pick an element and find some information about it. So again, we can see there's an IFC furnishing element. It's got a name, Bank Ops. I'm not sure what type of chair that actually is, possibly from IKEA. And we have some other information. We have quantities, whether it's existing, things like that. As mentioned, we've got two ways to view all this. We can view it as attributes, or back in our BIM menu, we have IFC properties. So again, we can actually go and pick that chair. The difference being with the IFC properties is we have all the properties for the building. So you can see here's all our furniture in here. Come down, flow terminals, windows, doors, everything you would want to know. And the one thing about this is they break it up into stories. So we got first floor, we got second floor, and we got third floor. Okay. Now I mentioned clash detection. So what we can actually do here, if we take out all of our architectural data, except for our footings, and we'll bring in some utilities. Now it's quite obvious to see we've got an electrical conduit going straight through our footing, but we'll run the clash detection anyway. So up under design, check clash, we have our clash detection. And we can define our own custom rules. I have a very simple one here, which is basically checking our electrical against our architectural footings and a couple of clearance values. To apply those detections, we select our data, we select our rule set, and we add some models in. I've prepared one a little bit earlier to make life simpler. So you can see here we've got our electrical model, we've got our footings, we're using our electrical rule, we've got some models defined, and we're going to spit out a report as well at the end. And there's our clash detection report. So we can see there's one clash. Now on a job you might end up with a few hundred clashes. And you think, how am I going to find all these? Well, if we come down and pin out the output window, you'll see we've got some log lines here. So we select this clash, it'll highlight where that is in a 3D view and in a plan view. So we can see where our clashes are actually occurring. So all this data from architects is actually becoming very useful to civil designers. Now, often it's not just architectural and buildings we're dealing with. For a lot of people on the highway designs, you'll have bridges, because we can't build roads without bridges. So coordinating with structural data, much the same process as with architectural, except often bridges seem to know where they actually belong in the world. And that's because structural software can quite often define a project base point and a corresponding survey point. What this does is allow them to switch between their local grids or their architectural grid and the real world coordinates, and allows for importing and exporting data. Let's jump back into 12D. And we have our road design here. We've got a bit of a highway going underneath, and we just got a local road going over the top. So what we're going to do is read in another IFC file, but this time it's of a bridge. Now, this time I'm going to put it all on one model. And I'm just going to call it bridge. So if we read that in, finish that, add our model, and there's the bridge. No manipulating, no moving, drop straight in. We can come to our 3D view. Same again, we can add our bridge in. And there we go. Same with our cross sections. As we pan down the road, there's our bridge. So we've gone through how we get architectural and structural data into 12D. Now, where does BIM fit in with the civil world? Or more importantly, how does civil data fit in with BIM? So let's break it down. Starting with building. So what's this? A road. Moving on. Information. In 12D model, we have lots of it. We can do range files and we can inquire, we got attributes and more attributes and properties and so on and so on. We'll come back to that later. The modeling. So this is a model, and this is a model, and this is also a model. So the word modeling is a little bit vague and can mean anything. So back to BIM in the civil world. As we know, one of the main ideas behind BIM is information and exchange of that information. In 12D model, we have various kinds. We have properties, which are your name, color, volume, diameter, length, all that type of thing. And we have attributes. Now, attributes in 12D model can be project attributes, model attributes, tin attributes, string, segment, vertex, tri-mesh. I think that covers all of them. 12D model properties are different to attributes, and some properties may not be available outside of 12D model. So what do we do? Do you need to have those properties available? Should you create attributes from these properties? Do we want to know the 2D and 3D length? Do we want to know the diameter? When you're setting up your model, you should think about how you create your attributes and your pathing. Be aware of possible limitations and behavior of some software. Some software you'll find is actually limited to string attributes only. Segment and vertex attributes get ignored. Model attributes, tin attributes, that type of thing. Often they can be ignored. Consider the effect of your attribute names and case sensitivity. Are spaces allowed in names? Consider this: material depth, material depth, material depth. They're all the same thing, but they're all worded, all named slightly differently. How are attribute paths handled? Is anything beyond the top level attribute actually ignored, or will the software automatically flatten the path? Something like Celebri will take road material type and change it into road.material.type. IFC property sets, not to be confused with 12D model properties. They're different. Property sets allow for the grouping of attributes. So now our attribute paths in 12D can actually be dealt with via P-sets. So let's go and have a bit of a look at the attribute manipulator, because this is a tool we use to move all this stuff around. Let's go back to our road design for a minute. And we'll take a look at some of our line marking. So you can see here at the moment we've put no attributes on this string. But we might want some of this information to actually go out. We know that if we bring up the properties, we've got the name, we know the color, we know the length, we know all this type of information. Up under utilities attributes, we have our create edit attribute manipulator file. Now I have one here prepared a bit earlier. If we read that in, And you see we can copy things like string property. So we can copy the name to an attribute. We can take the function name and put that as an attribute. We can take the 3D length and the 2D length and put them on as attributes. So now we've got information that normally wouldn't be available outside a 12D model. Suddenly we can start exporting it. To apply that, we simply apply the attribute manipulator file. So here we're doing a bit of filter. We're going to apply it to our LE strings and our lane strings. There's our attribute manipulator file, and we're just going to replace the existing data. So if we go ahead and apply that. Now if we come back to our LE string, we've got some attributes on here. So we've got the name, we've got the 3D length and the 2D length. Let's go over to our utilities. So we've got some pipes here. We've got some communications, electrical, water, we've got some storm water. Now remember I mentioned before about segment and vertex attributes not exporting. Well again, the attribute manipulator, we can deal with that. We can take segment attributes and we can apply them to string attributes. So we're going to do a very simple one here. We're going to take the segment property, which is the length in 2D, I'm going to apply it as a string attribute. Now the key here is the index. So the index number is the number of segments you've got. So the first segment is index 1, second segment is index 2, third segment index 3, and so on. By putting the index as 0, it actually applies it to all segments. When we go to apply that file, again, apply attribute manipulator file, load in. So we're going to apply it to our 3 models. And we've got this down here, one many manipulating mode. So we can ignore it, not allow it, or the one we want to use is append indices. So what it's going to do is going to number those attributes. So we get an attribute, string attribute for each segment on the string. So we go ahead and apply that. Pick one of our strings here. Come down to design, and we can see we've got our segment lengths, segment 1, segment 2, segment 3. Same over here, much longer one, 1, 2, 3, 4, and so on. So we can now start to put our segment attributes onto our strings so that we can export them outside of 12D. What else do we need to consider? Well, think about attribute overload. It wasn't too long ago the BIM managers were saying, we want attributes. And we were saying, well, what do you want? And they said, we want everything. So we gave them everything. Drainage strings, as we know, many attributes and some more attributes. Suddenly the BIM managers are turning around, hands in the air going, too many attributes, too many attributes. So again, attribute manipulator, we can move the attributes around, we can copy them, we can send out the ones that the BIM manager actually wants. Drainage is a little bit different because when you export it as an IFC file, it gets broken down into pits and pipes. So what this means is segment attributes actually go out on the pipes and vertex attributes go out on the pits. So drainage is a little bit of exception to the rule that segment and vertex attributes may not get exported. So we're talking about IFC files and we want to get the IFC file, get the data out of 12D. So the way to go is the IFC Express Writer. Now, the good thing about the Express Writer as opposed to the full-blown IFC Writer is the Express Writer is simple to use. It's quick and it's simple and does not require you to set up a spatial structure. You can also define or redefine the base point. You can select an origin, which is roughly in the middle of your project. What this does, it allows you to send out data for software that does not handle large coordinates. It allows you to coordinate with architectural grids. Do we want to export attributes? Yes, of course we do. So we tick that on. The other one to be wary of is output polylines as tiny pipes. Again, some software has trouble displaying polylines with no defined size. So by sending them out as very, very tiny pipes, they can actually display our strings on the screen. Drainage networks should be exported as IFC system. However, not all software handles it. So the big difference being, under IFC system, you'll have an IFC flow storage device and an IFC device, which is the pipe. If you turn that off, then all the drainage goes out as a very simple IFC building elements, so basically lumps of concrete. Again, something to be aware of with whatever system you're exporting to. And of course, multi-barrel drainage. Be aware, not all software can handle the multi-barrels, but the IFC format does allow for multi-barrel systems. Something which has been added recently to the Express Writer is the Use IFC Attributes tree. Now this allows us to deal with our groups and our attribute paths. Because what we can do, we can nominate a tree, and all the groups under that tree will actually go out as p-sets in the IFC file. Let's have a bit of a look. So we're going to use our utilities again. So we got our utilities and our drainage, and we're going to write them out to IFC. So you may have noticed before, we had some attribute groups on our utility strings here. We had a group utility, and we had authority and design. And we had one which was a little bit different. It had the utility, and also had this one called layout. Now when we nominate our attribute tree as utility, anything outside of that tree will actually be ignored in the IFC file. Also our drainage. We've got we've got a couple of barrels down here. So we'll show that this does actually go out to IFC. So up under our export, IFC Express Writer. We shall get our model list. We're going to leave the origin as 0. We want to output IFC system. And we want to use IFC attribute tree. Going back, so this is our tree. It's only one level, so it's nice and simple. We'll write that out. Now, the first thing to note, multi-barrel drainage, okay? Don't let anyone tell you that multi-barrel drainage isn't coming through in the IFC file. If we select one of our utilities, you'll see here now we've got these p-sets. We've got the standard 12D model property set, and we've got that authority and design. On our comms, you'll see we've got the same 12D model, authority, design, but remember we also had that layout group which has been ignored because it was outside the attribute tree. And that's simple as that. .12D model objects. Now, we've all done extrusions, line marking and fences, and we all know that they don't go outside of 12D. They don't go to DWG, they don't go to IFC. They're a 12D model object. They exist inside 12D model and they generally cannot be exported. Well, we have tools now to export them. We can convert those extrusions into tri-meshes, which allows them to then be exported.
Back in 12D, you probably remember we put some attributes onto our line marking strings. So if we just go and have another quick look at them, let's just pick our edge line. And you can see we had attributes. We had the name, we had the 3D length and the 2D length. So just close that down. Problem we've got, we don't have those attributes on our extruded line marking at the moment. Come across here, pick our extrusion, and there's no attributes. So we just need to rerun our chain to recreate our extrusions. So pop that one open, and we'll rerun that. And finish. Now if we take a look at our extruded line marking, we've now got those attributes have been copied across to our extruded line marking. So we can close that. Now we want to export that. So the way we are able to export our line marking is by converting the extrusions into tri-meshes. So up here under tri-meshes from 12D objects, we can select our line marking model. Turn off these. Note here we can also do pipes, culverts, drainage strings, pipelines. We're just doing our visualization and our extrusions at the moment. We want to copy the attributes to the tri-mesh, so we need to make sure we tick that on. And we'll pick an output model. We generate that. Done. Now if we come across and have a look at those tri-meshes, we can now see that the tri-mesh has been generated and it's got all our attributes on it, ready for exporting.
So what other options do we have? IFC has become the industry standard, mostly because it's widely accepted and it's data rich, it's information rich. All your attributes and your property sets and everything else go out. But at a pinch, we do have some other options. We have OBJ, we have FBX, DWG, KML and KMZ. So starting with OBJ, it's a very simple data. It doesn't support strings or tri-mesh, but it does support tins, drainage and pipes and things like that. OBJ also has a very limited design plane, so we need to specify an origin that's roughly in the middle of our project. So under export, we have OBJ. And again, I'm going to cheat a little bit. We're going to output our utilities again. I'm just going to output them to a single file, and I've already selected an origin in the middle, so I wrote that out. And there's our OBJ file. Even supports multi-barrel, but it's just objects. There's no information. I can't do anything with it except make it look pretty. FBX. Again, simple data, no real attributes. And one thing we found recently is that it's not always in the correct scale or rotation. There seems to be coming out in inches depending on the software, and it'll have 0 degrees set to the east or to the right rather than to the north. And of course the base coordinates will be down at 0, 0. Now to demonstrate this, we actually had our bridge in IFC file. We got an FBX of the same bridge written out. So we bring up these two views again. We're going to read in our FBX. just read that in. I've already got the view added. So these just come in down near 0, 0, and the size is actually the wrong size as well. But if you're stuck with an FBX, you can do your helmet. So of course, there's one I prepared earlier. Read that in. Apply to the model, and we want to replace the existing. Calculate that, and away we go. And you can see the bridge now nicely matches our other location. There we go. So FBX files, all is not lost. You can work with them, you can get the data in, and you can get it in the correct location. DWGs, well, we all know about DWGs. It's CAD data. It does have attributes, but you're limited to attributed blocks. When exporting the DWG, pipes and drainage will only go out as polylines, so you need to use that convert to tri-mesh. So the same as we had before, convert them to tri-mesh and they will go out into the DWG file. KML, KMZ, your Google Earth files, it's not survey accurate, but it supports strings and tins. One thing is the design is not merged with the surface in Google Earth, so you don't have holes where you're in cut. So if you're going through a big 10-meter cut, all you'll see is the existing surface. But it's a simple solution for portable data. You've got your options available to follow the Google terrain or extend it above the Google terrain. If you're choosing actual elevation, be aware that your road may disappear under the existing surface. So where to next? Well, there's already the precinct information modelling floating around out there, or known as PIM. IFC 4, the civil BIM, is coming out, and IFC alignment will also be not far behind. So for a bit more information, be sure and catch our IFC and civil BIM webinar by Dr. Lee Gregory himself coming up in a few weeks' time. I'll hand you back to Lisa.
Wonderful. Thanks, Joel. I think that was pretty comprehensive today. We haven't had too many questions through, so we'll chat to people by email later there. And our next two Industry Solutions webinars will be Automating Document Admin on the 29th of March, and as Joel mentioned, IFC and Civil BIM on the 5th of April. So do register for those now if you haven't already, and keep an eye on our emails and social media channels for more great upcoming topics in this and our training series. And don't forget, we've got our Tech Forum coming up in Brisbane this July. That's got the associated Innovation Awards as well again, so that's closing on the 30th of April, so do enter now for a shot and an amazing prize in that. And if you need to contact us in the meantime, we'll pop some details on the screen. That concludes our presentation for today. Thank you everyone for attending, and we hope to see you at future webinars.